just a brief overview of what lattice energy, or how did we calculate lattice energy. You had born-haber cycles. That was kind of like a Hess cycle for ionic compounds. Uh, you start off with enthalpy of formation of an ionic compound like an MgCl2. So elements would join up, react together to form MgCl2 solid. So it's Mg solid reacting with Cl2 gas, and it would produce MgCl2. And the other way is the stepwise detailed method of making MgCl2 is the first thing is you would break the bonds of Mg and you would break the bonds of Cl2, and you would atomize the two substances. So the metallic bonds in Mg are going to break. So that's enthalpy of atomization of Mg, and the Cl-Cl bonds would also break, and that would give you Cl gaseous atoms. Once you've made these gaseous atoms, then you're going to ionize them. So the next part was making them into ions, turning them into ions. So it was Mg that was going to lose 2 electrons, so it would form Mg2 plus, and the Cl would gain electrons, so that was electron affinity of Cl, and it would become -1. And the final part was that the gaseous ions would get together to form this solid ionic lattice, and that would be known as the lattice energy. So one path is equal to the other path according to the Hess law. So you've got two paths. One is the direct path, and the other one is you go all the way. So one path is equal to the other path. So if lattice energy is not known, you should be able to figure out what lattice energy is. So we're going to do some past paper questions. Okay? So for example, this one. You're being asked to calculate the lattice energy of potassium oxide. So you're going to make a similar Hess cycle. So elements, which in this case would be potassium solid plus O2 is going to be in gaseous state. They're going to combine, react together to form K2O, which is an ionic solid. And this is known as the enthalpy change of formation, delta HF. Like 1 mole of K2O is formed. So there's going to be 2 Ks, and there's going to be half O2 gas molecules, right? So this is enthalpy of formation, and the value is given over here. That's given as minus 361. That value is provided. Okay, is this clear, Saqib? Is this clear, Kausar?
Yes, sir.
Now, we're going to try and figure out the other route, which is going to be you atomize potassium. So it's going to give you 2 potassium gaseous atoms. Keep half O2 as gas as it is. So that's one. What is enthalpy change of atomization of potassium? That's provided over here. That's given as plus 89. So that's plus 89 times 2. So that's enthalpy of atomization. You have to be very careful about the moles of substances. Next thing is key potassium has already been atomized. Now you have to form atoms of oxygen. Now the way you're going to form atoms of oxygen is that in an O2 molecule you would break the O double bond O, and that would give you an atom of oxygen. So there's going to be half O double bond O molecule needs to be broken. So that's basically half times 496. 496 is the bond energy. I mean, there's a data booklet open somewhere, just a second. So 496, right somewhere at the top. So breaking the oxygen double bond is 496, but that would give you 2 oxygen atoms. We just need 1 oxygen atom, so that's going to be half of that. So half moles are going to be broken so that you get 1 mole of oxygen atoms.
Sir, पिछले question में when we were doing this, you weren't considering मतलब ये gaseous atoms वाले moles. मतलब I don't remember it. Like you said we won't consider it over here because of the fact कि वो पता नहीं ions थे कि क्या थे, and you weren't considering the number of moles, and you just directly wrote the bond energy.
For example, over here. कि 2Cl atoms form हो रहे हैं ना.
जी मेरे ख्याल से.
नहीं, if 2Cl atoms are being formed, you're breaking how many bonds? Just one, right?
जी.
So, but if your equation has, I mean, it depends on every equation. Like you wanted 2Cl atoms, right? So in this case, you wanted 2Cl atoms. So how many bonds would be broken? Half of them, right? No, sorry, one of them. Clear? What if
अच्छा.
what if
ओ.
you wanted one Cl atom? But if the Hess cycle had one Cl atom, right? So to get one Cl atom, you're not going to break one bond. You're going to break half of them, well, half moles of this, because this is going to give you two Cl atoms. Is that clear?
जी जी.
Achha, so we've reached this point. The next part is ionizing the substance. So let's make K lose electrons. So that's two potassiums turning into positive ions, and they would be losing not one electron, but actually two electrons. So they would be losing. Okay, they draw. So they would be losing two electrons, and you forming gaseous atoms. Oxygen as it is. Nothing happened to oxygen. So how much energy is spent when potassium loses electrons? So again, open the data booklet somewhere over here. There must be potassium. I mean, there has to be. So you've got potassium, and there's 418 and C070. Okay, these two values. No, not these two values. Potassium only loses one electron, so that's 418 only. Always remember this first column is for the atomic number. It's not the ionization energy, so it's 418 only. So so this would be 418, but multiplied by 2 because you've got two potassiums. Okay, remember that each of the potassium is just losing one electron, so it's only 418, but multiplied by 2. And the next step would be that oxygen gains those two electrons. So it's potassium has already lost electrons. Now those electrons are gained by oxygen minus 2 and turns oxygen into minus 2. So that's the electron affinity of the oxygen plus the electron affinity of the oxygen minus 1. So that one is minus 141 and plus 798. And the last step is your lattice energy. So you've reached the other point. So what's your expression going to be? It's going to be one path is equal to the other path, so that's one path, and that's an equivalent path. So it's minus 361, and that minus 361 should be equal to all the other things. So it's going to be 89 times 2, and it's going to be half into 496. Then it's going to be 418 into 2. Then it's going to be minus 141 plus 798. And then it's going to be plus lattice energy. Okay, all of this. Can anyone do the calculation? Tell me what, if you make lattice energy the subject of the equation, what is the value that you're going to get? Okay, I'm going to try and do the. And you have to be very careful with the signs that you use. So lattice energy, take everything on the other side. So it's going to be minus 361. Okay, be very careful. Then it's going to be minus. Just use. So it's going to be minus. Just use brackets. 89 times 2. Uh, then it's minus. Again, I'm going to put brackets half 0.5 times 496. And then it's minus 418 into 2. So what else? Then it would be plus 141. And then it's going to be minus 798.
So it's minus 2280. This is what I get.
ठीक है, so it's coming out to be
What the
minus 2, ठीक है, minus 2280. That's the value that we are going to get cos of ठीक है, that's right. So it's minus 2280. Remember, lattice energy would be somewhere around minus 1000 to minus 4000, usually close to that. So that's your answer. Now the next one is state whether the lattice energy of sodium oxide would be more negative or less negative or the same as that of K2O. Which one is the stronger lattice? Sodium oxide or is it K2O? Both of them are in group 1. Sodium is the smaller ion. ठीक है? Sodium is the smaller ion. So which one is going to be the stronger lattice?
Sodium.
ठीक है? So sodium is going to be the stronger lattice because smaller ions, they always make stronger bonds. So it's going to be more exothermic, this one. And you're going to write that since they have the same charge, it has a smaller ionic radius, so it's going to make stronger bonds. It has greater charge density. So you're going to talk about the charge density in this case. And the next question, it's very similar. It's about sodium oxide now. And this time, they've actually made the born-haber cycle. Now, the only difference is that your born-haber cycle was just a cycle, random cycle, but over here, they're following the energy guidelines. Like, if it's endothermic, it goes up. If it's exothermic, it comes down. And he's asking you to label it. What is 3? What is 3? What label would you give to 3? Gaseous ions.
Lattice energy. Sorry.
You get lattice energy. Gaseous ions turning into an ionic lattice. That's lattice energy, and it's always exothermic. So which is why the arrow is coming down. What is number 4?
Enthalpy change of formation.
ठीक है, that's delta HF. ठीक है, so that's delta HF because you've got elements in the standard state and they're forming 1 mole of a substance. So that's enthalpy of formation. What's number 1? Ignore number 1 for now. What's this arrow? 2 times enthalpy of atomization of Na. So Na solid would be turning into what?
Gaseous sign.
Plus
Gaseous. Sodium.
Sodium gaseous, right? Remember, atomization is when you just form gaseous atoms, okay, not ions. So what is 1 in this arrow, in this step? Nothing happens to oxygen, so it has nothing to do with oxygen. Oxygen is the same.
Enthalpy change of ionization.
Okay, so it's the it's the first ionization energy of Na. Like you have to be exact. It's first ionization energy of Na multiplied by 2 because you have 2 in it. Okay. So next one is enthalpy of atomization of oxygen. So what would happen to oxygen over here?
Electron affinity.
Atomization of oxygen. Oxygen atoms would be formed.
One, it's like O.
Okay, just O, gaseous. States are important. So what is happening in 2? Na is +1, Na is still +1. So nothing happens to Na in 2. Oxygen is gaseous. Now it's oxygen -2. So what is this?
Electron affinity. Electron affinity.
So it's the electron affinity of oxygen plus the electron affinity of oxygen -1.
Second ionization.
Sodium. Nothing happened to sodium. I mean, sodium was.
क्योंकि नीचे आपने खाली फर्स्ट आयनाइजेशन की मेंशन की है, यहाँ पे दो सोडियम पार्टिकल्स है ना. हाँ, वो into 2 हो जाएगी ऐसा.
वो तो कर दिया ना, ठीक है. मतलब लेकिन just focus on this step. Nothing is happening to sodium. I mean, this step has nothing to do with sodium. Sodium was exactly the same as before. यहाँ पे it's exactly the same. So in step 2, nothing happens to sodium. Saqib, is this clear?
Yes, sir.
ठीक है.
Still, I don't understand why adding up here. electron affinity of oxygen and oxygen negative.
It's forming oxygen minus 2. So how many electrons would be
See,
added?
so
I mean, first oxygen would gain electron, so it would turn oxygen minus 1. Then oxygen minus 1 would gain electron to turn into oxygen minus 2.
like, won't we simply multiply that value electron affinity of oxygen by 2?
No, you can't do that. But I mean, it's not okay. I mean, for example, it's every time. I mean, it's oxygen gaining an electron is going to have a different value, and oxygen minus 1 trying to gain an electron is going to have a completely different value. Is this clear?
ये
Okay, they're completely two separate
Acha,
reactions.
yeah.
ठीक है, they're completely. So oxygen, you want to turn oxygen atom into oxygen minus 2. So this is one reaction. The first electron affinity is exothermic, and the second one is usually endothermic, because it's a lot more difficult for for oxygen minus 1 to gain another electron. So they're two completely different reactions happening. Over there, we multiplied it by 2 because it was the same thing happening, but 2 times. Like it was Na losing 1 electron, but there were 2 sodium atoms. So it was the same reaction happening twice. So it was ionization energy of sodium multiplied by 2. So is this clear?
Yes, sir.
Yes, sir.
Now, the next, so that was pretty much, you just had to identify everything. Let's talk about, I mean, this is again sodium oxide, so we can ignore sodium oxide for now. Let's try and make calcium chloride, a born-haber cycle for calcium. I think we did this question in class. This was the question I gave you. I just forget that. Let's talk about this one. Now he's saying, use the equation of following data and relevant data from the data booklet to calculate a value for the lattice energy of MgCl. So he's asking you to calculate the lattice energy of MgCl. What's wrong with this formula? I mean, he's exactly saying MgCl. Can somebody tell me what's...
There's no 2 for chlorine. There's only 1 chlorine atom.
That's exactly what's wrong with this. Because what we know of is that Mg forms a 2 plus ion, right? Because it's in group 2, it doesn't form Mg plus 1. Now the problem is, he's saying that it's Mg plus 1 in the formula. So we're just going to follow that. That means, and he's specifically asking us for the lattice energy of MgCl. So we're going to stick to it. We're not going to make it MgCl2. We're just going to, I mean, if he's saying that Mg is plus 1, we're going to continue with Mg plus 1. So everything is given. You have to find the lattice energy of, remember, specifically MgCl. So starting with enthalpy of formation, Mg solid and Cl2 gas, they would react together to form MgCl. And this would be half. And this is your enthalpy change of formation. Then what you're going to do is you're going to atomize substances. So I'm just going to be quick. I'm going to try and atomize the substances in one go. So it's going to be Mg turning into gaseous plus Cl also turning into a gaseous substance. So I've done that in one step. So it's basically enthalpy of atomization of Mg plus I would have to break the Cl-Cl bond, but half of them. So it would be half of the Cl-Cl bond energy. So I did it in one step. I'm going to do the ionization in one step as well. I want to turn Mg into Mg plus 1, and the electron lost would be gained by Cl. So it's the ionization energy plus. So I'm just trying to simplify the born-haber cycle. I mean, if they're asking you to draw it, you draw the whole of it. I'm just combining steps so we can do it quicker. So Mg is going to lose one electron. How do I figure that out? It's probably given in the data booklet over here. How does Mg? So that's 736. Remember, we're not going to talk about 2 plus because he's not asking for 2 plus. So it's 736. And then Cl needs to gain an electron. So electron affinity of Cl is given over here. That's minus 349. So that's two steps combined into one. And the last step is my lattice energy. That's unknown. Enthalpy of formation is also given. That's minus 106. So basically, it's one path equal to the other path. So it's this equal to this entire thing. So it's minus 106 is equal to what is enthalpy of atomization of Mg? That's given as plus 147. What is the bond energy of ClCl? We want half of that. So where's the ClCl bond energy? That's over here 242. So this one is 242 divided by 2. Then you got 736. Then you got minus 349. And lastly, you have lattice energy. So try and solve this and tell me what the value is. Has anyone tried it? Okay, so we are getting minus 550.
Sir, I'm getting negative 761.
Okay, just let me quickly. Kosa, did you divide 242 by 2?
Yes.
So 1 second, let me. Let's remember, be very careful with your calculations. A tiny mistake. So it's just quickly minus 106. Then it's minus 147. Uh, then it's minus what's 242? 121. Uh, then it's minus 736, I think. And then it's plus 349. That's it, I think. I'm going to minus 761 as well. Kosa, can you identify your mistake? It's minus 761.
Okay.
TK, just be very careful. Don't make any mistakes in your calculations. As anyways, so now this part. Which one is the stronger lattice, MgCl2 or MgCl?
MgCl2.
And why?
Because there are two electrons being donated. There's greater attraction.
TK, so MgCl2 has is more exothermic. It has a stronger lattice. So this one is more exothermic, and it has a stronger lattice. And the reason for that is it's got a greater ionic charge because it's 2 plus. So there's more attraction, and which is why it's going to have greater charge density as well. Plus, another thing about Mg2 plus is that it's going to be a lot smaller as well. Not only has a greater ionic charge, it has a smaller ionic radius as well. So there are two reasons for that. Why does it have a smaller ionic radius? Because Mg2 plus loses its outer shell. Mg plus one doesn't really lose its outer shell. I mean, I mean, there's a place I think where ionic radiuses are written. Need somewhere. somewhere after this, as well. There's definitely a section where this one. So I don't know if Mg. So they've written the Ionic radius for Mg2 plus. But remember, Mg1 plus is going to have one entire shell. Like if I just to clarify this, Mg atom. So this is what an Mg atom looks like. Now Mg1 plus is going to have an outer shell. Mg2 plus is not going to have an outer shell. Is this point clear? Zahib, is this clear?
Yes.
Yes, sir.
Acha, what about NaCl and MgCl?
NaCl.
Acha, now in this case, the charges are the same. +1, -1, +1, -1. Which one do you think is smaller? Na has 11 electrons, +1 means it has 10 electrons. Mg has 12 electrons, but +1 means it has 11 electrons. So it's again, Mg is bigger. It's got 3 shells. I mean, it's 281. Na is just having 2 shells. So the charge is not a factor, but remember Na +1 is smaller. Okay, it's smaller and it has, which is why it's going to have greater charge density. Similarly, let's see if we have another question. Again, I don't know why there's so many sodium oxide questions. Similar question. So we've got AGPR. So we've got. Let me see if there's a slightly more difficult one. So we can do BAS. I mean, try and solve this one. Okay, that's your. Try and do it right now. Okay,